So our lesson for today is about the proposition. So proposition is also called as the sentential logic or the statement logic. It is a certain thing that can be true or false. So subject terms and the predicate terms make a proposition taken as a whole. So that is the proposition. So in other definition, proposition is also a declarative sentence, either true or false but not both. It is also a sentence that has a truth value. So truth value. The truth value is true or false. That is represented by an T and an F. Let me give first an example. So the first example is 6 is an even number. So take a look at this example and analyze this statement. So this statement, I can say that it is a proposition because 6 as an even number is considered as a proposition and the truth value is true. Because this statement is also known as the universal truth. So this example is a proposition and the truth value is true. So let's go on into the next example. So Anna is lazy. Anna is lazy, so understand the statement and take a look at it carefully. See the difference in the first statement that I've gave. So this example contains an adjective and a subject. So this is the adjective and this is the subject. By that case, you can see that this statement is an opinion. So we considered it as a not universal truth. Maybe for her, Anna is not lazy. Maybe for me, he's hardworking. So it considered as a opinion. So this is a non-proposition example. So let's go on into our third example. So the third example is the earth is flat. So you can now understand the statement. So the earth is flat came from the word itself, flat. So this statement is considered as not universal truth because the truth value is false. Because we are aware that the earth is not flat, so we consider this as a proposition, but the truth value is false. Let's go to our fourth example. Let me give you an example that is quite different into the other example that I gave to you. So in this sentence there is a word please. So please, which means a command or a request, so it is not considered as a proposition. Going back to our definition, which states that the proposition is a declarative sentence. So this is a command or request, so this is not a proposition. So note that this is a note, okay? Remember all of this. So note that P, Q, and R are used to represent statement, but we can also use other letters on representing, but these are the common letters that we use in propositions. So these letters are called propositional variables. Our next topic is symbols and operation. So symbols and operation is about the operators or the connectives that we use to create a compound sentence or connect a sentence. In using operation to connect sentence or the statements, we use symbols to identify on what operators are being used. So let's start on familiarizing ourselves. The first operation is the conjunction. So let's proceed to conjunction. So conjunction is being denoted denoted by this symbol. This symbol is read as a end. So the symbol means end. So for example, P, the symbol, and then Q, this is read as a P and Q. So in conjunction we have conditions. So the condition is P and Q is true if both statements are true, and we can say that it is false when P and Q is false or either one of them is false. So I would give an example. I would consider myself as the example for you to get it more. So example is, let our P be the I am a student, and our Q would be I am a poet writer. So this is a real life situation. So basically this two statement is true because I am a student and I am also a poet writer. So P and Q is true. So that's why both statements are true. So therefore P and Q is true. So let's make another example. So let our P be the 5 is rational number, and our Q would be 15 is a prime number. It is in the condition of conjunction that either one of them would be false, the whole statement would be false. So P is 5 is rational number, and then Q is 15 is a prime number. So we know that P is a proposition, that's why it is true. But Q is not a proposition, so it is false. Since we know that 5 is really a rational number and Q is not a prime number, Q is considered having a truth value false. So therefore P is true but Q is false. So this P and Q considered as false, because it is in the condition of conjunction that either one of them would be false, the whole statement would be false. So always take a note that in conjunction, we also use other conjunction or the connectives like the but, yet, or, while, and even though. We use it to make a compound sentence. Since we're done in our conjunction, let's move on into our next operation. So our next operation is this junction. So this junction is denoted by, so this junction is denoted by this sign. It's like a V. Yeah, there it is. It is read as or. So when we say P in the symbol, then Q, it is read as P or Q. Like in conjunction, there is also a condition when it comes to P or Q. So P or Q can say that it is true when both statements are true, or either P or Q is true. And we can say that it is false when P and Q is false. So for you to understand it more, let me give you an example. So our first example, let our P be the January has 33 days and our Q as February has 30 days. So our P here is false, since January has 33 days is not true. We know that January has only 30 to 31 days in a year. And our Q is also false, since February only has 28 or 29 days in a year. So this P and Q, this statement P and Q, or P or Q, is false. So our next example. Let our P be the I am a grade 11 student and Q I am a professional author. So P is considered as true, since I considered myself as a example in here. So this P is true, while our Q is not true, so it will be false. So our P or Q is also true, since in the condition as either one of them is true, it is considered as true. So the fourth lesson is simple and compound proposition. Simple proposition, or also called as atomic proposition, contains only one idea. Simple proposition can be combined to give a compound proposition using connectives like and, or, but, and the likes. And compound proposition, this is quite different to simple proposition because this contains two ideas, or it can also be a simple proposition but joined by logical connectors, or what we call connectives. So to make it more easier for you, I will give you two example of simple proposition. So the two example of simple proposition is the P sub 1, which is it's rainy day, and the P sub 2, which is I am wet. So these two statements are considered as a simple proposition because it contains only one idea, which can seen at these two statements. We can create a compound proposition by using logical operators. Since I told you before that we can create a compound proposition using the connectives or the logical operators, we already did some examples here for compound proposition. So these are my examples for compound proposition. This P sub G, which is it's rainy day and I am wet. I use the connector and to create a compound proposition using the first two statements that I've mentioned in you a while ago. So this connect word or the logical connector and. Then the next one is the P sub 4, which is it's rainy day or I am wet. So I use here the word or to see the connections of the two statements, since the definition of compound proposition contains two ideas. So this statement contains two ideas already. So it's rainy day and I am wet. So here it goes as same as the P sub 4. So the next is the P sub 5. In this P sub 5, I try to connect all of the two operations in here. So our P sub 5, it's rainy day and I am not wet. So in this statement, you can see that there is a quite different in the first two sentences, and it is the not. I use negation here for you to know the possible statements that we can construct using the connectives and the operations. So this statement also contains the two ideas, and we can say that it is also a compound proposition because of this word and the not. So this is a compound proposition. So that's all for the proposition, and of course we can write these statements into this. So P sub 1 and P2. So we can write this as like this. So the next one is P sub 1 or P sub 2. Then the P sub 1 and not P sub 2. So these are the key points in here. So this is how you write this when it comes to using the operations and the connectors when connecting two statements, of course. So that's all for the simple and compound propositions. So the last lesson is the truth tables. Truth tables given a proposition. This shows all the possible truth values of a proposition. So how do we construct tables when it comes to truth tables? So constructing truth tables is always depend on how many propositions do you have. For example, you have two propositions, so it would be 2 raised to n. So you have two propositions, so it would be 2 raised to 2. So 2 raised to 2 would be 4. You have 4 rows to make. So when making a truth table, when it comes to conjunction, always remember the condition that we discussed a while ago. So in constructing a table or a truth table in conjunction, we have, for example, we have P and Q, and then P and Q. So it would be true, true, false, false. We have to give all the possible truth values of each proposition. So it would be true, false, true, false. Then you just have to get the truth values of the P and the Q. So what is the truth value of the P and the Q? So true, true, since the condition is it will be true if both of them are true. So this would be true, then all of them would be false, since they have the false in here, and then false in the both. So we just have to consider the condition. So after the conjunction is the disjunction. Let us also do the example like the first one, which is the P and the Q, then the P or the Q. So let's just keep all the possible truth values that we can have. So truth, truth, false, false, then true, false, true, false, true. So in doing the disjunction in all the operations, we just need to consider all the the conditions that we have discussed a while ago. So T and F would be true, since the condition there would be the statement would be true if the truth value would be true if either one of them is true or both of them is true. So these are true and this would be false, since these are both false. False, then true. So here is the P or Q. So let us now proceed into the negation. So in negation, we just need to give the two possible truth values. So we can say that it's true and then false, and so for example is P, the negate of P, the negation of P. So when you negate the true, it would be false. When you negate the false, it would be true. Simple as that. That is the negation.